So I'm here tonight because I came to the last meetup and I started talking to some people about this project I've been working on. They kind of convinced me to submit a talk, but it's been a very long time since I've done a technical talk, so I'm a little bit nervous, but I'm sure you're all nice, friendly people.
We are.
So, hang on, let me get my tethering going. While that's hopefully connecting. Tonight I'm here to talk to you about serverless and IoT. They're kind of like, I guess, two big buzzwords really. But it was a really fun project that I got to work on, and I got to learn a lot about these two topics. So I kind of wanted to share what I learned. If we can connect. All right. So, who am I? My name is John McKim, and I'm a software developer at A-Cloud Guru. A-Cloud Guru is an online, on-demand training system for people that want to learn about AWS. I'm also a contributor to the Serverless framework. So, at A-Cloud Guru, we're an entirely serverless learning management system, so we don't run a single server for the entire platform. Is anyone here familiar with it or has heard of A-Cloud Guru? Yeah, cool, there's one or two. If you want some stickers afterwards, I got too many stickers. And what we do is we produce, we produce courses on AWS by engineers for other engineers. So, and we do that really cheaply. The courses are something like $15 to $80 compared to the $400 or thousands of dollars that you could spend from buying it from AWS. We've recently launched a new serverless course. So if you go away from this speech thinking, you know, I'm really interested in serverless, I want to learn about serverless, you can go to brisbanejs.acloud.guru and you can get access to that serverless course for free. The serverless framework is also a big part of what I do at the moment, contributing to that. It's a really good tool for deploying and defining serverless systems. It was initially Jaws, if anyone's heard of that, but it changed names earlier this year. At the moment, it only supports building serverless systems on AWS, but they plan on developing support for Azure, Google Cloud Platform, and IBM OpenWhisk as well. There are other frameworks out there, but this is the one I really like and the one I contribute to. So what will we talk about tonight? So we're going to talk about what is serverless. Is anyone familiar with serverless, or is it a bit of a new thing? Yeah. We're going to talk about why I built this project, the architecture of this project, the design of each microservice in this project, what is GraphQL and how to use GraphQL and Lambda, and then what I learned building this project. And questions at the end. So what is serverless? 90% of the people that I talk to about this, the first thing they say is, oh, you know, there's still servers. And yes, I know there's still servers. If you don't realize there's still servers, I don't know what's going on, but that's not the point. And the servers aren't, the point is that the servers are not your problem. And beyond that, serverless architectures are much more than just getting rid of the server. The serverless part that most people think of is function as a service services like AWS Lambda or Azure Functions that allow you to just execute code on demand. But serverless, like as a concept, is about using that as glue with all the other systems out there. AWS often talks about not treating your servers like pets, treating them like cattle, but now they're talking about using the herd of AWS services. But it's more than AWS services. There's great services out there like Algolia, Auth0, Firebase, and Netlify that you can use together to build these really powerful event-driven systems. So my definition of serverless and a serverless architecture is an event-driven system that utilizes FAS, functions as a service, and other fully managed services for logic and persistence. So why would you do it? The most obvious and immediate one to think of is that it's a lot easier in terms of operations management. You're outsourcing the patching, lots of the security of your servers to people like Amazon, who are really good at that, probably far better than you, far better than me for sure. There's also a reduced operational cost because you pay for the time that your code executes rather than the time that your servers are running. So when we're talking about cloud system, we're always aiming for auto scaling, but we're never really getting to say like 80 or 90 or 100% utilization. It's always going to be less than that. But with this model, you're really getting, pretty much 100% utilization in terms of cost and code execution. There's also potentially a big reduction in development time and therefore cost as well if you use this philosophy. By using the best-in-class services out there that exist, you're not spending time building these things yourself. You're just spending time integrating them and then getting them to work. It's highly scalable, and it's also, if you pick the right services, it's no effort. Scalability, that's the provider's responsibility, not yours. And if you're doing it right, you develop these loosely coupled systems, which then microservices has its, benefits and drawbacks, but they can be really easy to maintain if you do it properly. So why did I build this project? So I attended a meetup in February this year where my now boss spoke about building serverless systems, API Guru, and I left it really inspired. I was thinking, oh my God, this is the future. And I wanted to learn more about it. So I went away and started doing some Hello World projects. Like the first one I did was converting an Express app onto AWS Lambda, looking at like the requests and response templates and also authentication and things like that. But it doesn't really give you an understanding of how to build a larger real world style system. So for that I needed a problem and I needed a way to solve it. So I love gardening, but I often forget to water my plants and they sometimes end up looking a little bit like this. And I needed a way that I could monitor the moisture levels on my plants and also have my garden tell me when I have to go and water my plants so that I don't forget. And this is what I built. I could have just set a few reminders, but this was funner. So there's 4 main microservices in this architecture. I've got the React single page application. Can you see my mouse when I do that? Yeah, great. On the front end, and it's just a standard single page app. It's hosted on Firebase. I won't talk too much about that. I've got my web backend, which consists of an API gateway endpoint, a GraphQL handler, a Lambda that handles my GraphQL requests, and a DynamoDB table. For my notification system, I've got a Lambda to check the moisture levels that are coming in, an SNS topic to trigger another Lambda, which then sends a message to Slack to tell me go and water your plants. And the final system is the Iot Hub. So this is very AWS based, so if you're not familiar with AWS, I'll try to explain about each one and what each of these things does. But basically, in this system, I have actually very little code. The vast majority of the code of this system is in the front end. Then I'm using things like Auth0, API Gateway, DynamoDB, the IoT services to do all that heavy lifting that doesn't really, I don't care how that happens, it just needs to happen. So let's look at the IoT service first. So this is my input from my devices into AWS. This allows me to have a device in my garden that will send a message to AWS and enable me to act upon that. So the 2 things I need to do there, I need to store that data for my web backend so I can query it and use it as a dashboard. And I need to trigger an event in my notification system so that I can start the process of deciding whether to send a notification. So how does this system work? This is straight from the AWS website. The two main parts I want to talk about are the device gateway and the rules engine. So the device gateway is what I really think is the heart of the AWS IoT service. It facilitates communication and authentication and authorization between devices and AWS. The rules engine is like the brain. It processes messages and then performs actions based on those messages. So the device gateway works using three protocols. We've got MQTT, which is a really lightweight pub/sub protocol for IoT devices. We've got MQTT over WebSockets, which you can of course use with browsers. The IoT service isn't just for devices, you can use it for browsers as well. And then HTTP, which I kind of think is a bit of a last resort. Then these devices and systems need to be authenticated. So there's three ways to do that. You can use X509 certificates, which with mutual TLS authentication, that's like public-private key pairs. We can use AWS's IAM system and sign the requests. I haven't used that before. And AWS Cognito as well, you can use that, but I haven't done that. The reason I'd used MQTT is because the X509 certificates is because if you're using MQTT, it requires X509 certificates. And it requires TLS 1.2, which I'll talk about later. So that's a lot of theory. Let's look at what a device might actually look like. I've got a test JavaScript device that I use to develop this because doing the hardware side is, I kind of wanted to do that separately to actually getting started with this system. So I've imported the AWS IoT Device Sdk. I just have to set a few configuration variables where my certificates are, a name for my clients, and where I want to send it to. And then I connect this device to AWS. Once that device is connected, I can start publishing messages and sending information into AWS to be processed. Let's have a look at how that works. So this is what I use when I am developing projects. I've got this little script that will do what we did before and just start sending random moisture levels from my computer into Amazon. And I'm just going to leave that running for the rest of the presentation because we'll use the data that's getting sent up now later. So the rules engine, now that we can communicate with AWS, we need a way to process that data and do something with it. We do that through an SQL statement of all things. It felt really weird to me at first, but it kind of makes sense. So we can select from an MQTT topic that we're using to send messages to the system. We can use a select statement to transform the data, and you can use JSON expressions with that, and where statements to conditionally act upon that data. So an example looks like this. Select these properties from my message from this topic that I'm sending to. And once we're getting that data into the rules engine, we can take actions on it. So we can invoke things like Lambda, which is our functions and our logic to perform further tasks. We can just straight store that. If we just need to access the raw data, like I'm doing in the web backend, I can store it in DynamoDB or Elasticsearch. Or I can put it into other messaging systems like Amazon's SNS system, SQS, or Kinesis. We'll talk about those later. Or I can use CloudWatch or republish that message onto another topic so perhaps another device could pick up that same message. And to build this system, I didn't write a single bit of code. All I had to do was configure some CloudFormation templates, which is Amazon's way of defining your AWS resources, and this is the main part of that. All I have to say is I want to get this data from my soil moisture topic, and then when I get that data coming in, I'm going to store it in DynamoDB, and I'm going to trigger a Lambda function. And those two actions form the input of my other services. So let's take a look at the notification service. The notification service is what sends me a Slack message when my moisture level drops too low. So this service is a really good example of using Lambda as glue. My Iot Hub sends a message to my moisture level check Lambda. If the moisture level is too low, it publishes a SNS message, and then SNS triggers my Slack notifier, and then the Slack notifier sends a Slack webhook, which eventually gets to me. Might seem like a bit of a convoluted process. You could have done it all in one Lambda function if you wanted, but the reason I built it this way is that you have single purpose functions. So the moisture level check only knows about checking the level of the moisture and sending an SNS message to whomever. The Slack notifier only knows about interacting with Slack. So it's highly cohesive, it's loosely coupled. SNS isn't the only option I could have used. There's a couple of other messaging services on Amazon, but they all have their advantages and disadvantages when you're using it with AWS Lambda. So SQS is Amazon's fully managed queue service. Systems can go drop a message on that queue, and then a single consumer can go on and pick those messages up for processing later. It's just a basic queue. So the benefits of this system is that it has this thing called dead letter queues. So if your processor is failing and not processing messages out of that queue, Amazon will push those onto a dead letter queue so you can see, this stuff's failing, I might need to act upon that later, which makes it really reliable. The disadvantage is that it doesn't integrate with Lambda. So you can set up your own system with Lambda to pull those messages off the queue, but you have this problem where if you set it up in a really basic way, it doesn't scale at all, and you can end up with a log jammed queue. And to set it up so that it scales is quite convoluted. You need to use DynamoDB tables and all sorts of things to get that to work. And the other disadvantage is you only have a single processor on the end of that queue. Once that processor takes the message off, nothing else can get that message. So an alternative option is Kinesis, and Kinesis is just a stream, like a producer-consumer pattern. So I've got many producers sending data into this stream, and then my consumer reading off that stream, just like any old file stream, really. So the benefit of it is that it integrates with Lambda, and kind of like a file stream, you can get messages in batches, and they're ordered as they come in. The disadvantage of it is that it scales to 1 Lambda per shard. Oh no. And you can end up with the same kind of logjam problems. So when say a Lambda starts failing and doesn't take the current batch off the end of the stream, that batch kind of just sits there until it expires, or is processed. So you can end up with messages queuing up and not being processed properly, which isn't really ideal. And the fact that messages kind of just expire and don't really fail into a way that you can then handle later isn't great, in my opinion. It might be entirely acceptable, and it would be entirely acceptable for a notification system, but there's other reasons why I chose SNS. So SNS is a pub subsystem. You say, I'm publishing this event, and there's potentially many things that could publish that event, and then lots of different things could listen to that event. So the benefits of it is that it integrates with Lambda, and you're able to fan it out to multiple Lambdas. So with my notification system, if I wanted to add a Facebook Messenger bot or an SNS message notification and really annoy my users by sending them all at the same time, I could do that really easily. The drawbacks is that you have a really small message size that you can actually send. It tries 3 to 5 times and then just gives up and drops the message. But for a notification system, that's fine. And for this test project, I don't really care. So that's enough architectural chat. Let's have a look at a bit of code. So the 2 slides I'm about to show you is the sum of the code in my notification system. It's really very minimal. I get an event from the IoT service saying that I've received a message with this moisture level. I then just check if that's below 2.5, And if it is, I go and publish an SNS message to my system. I then have my Slack notifier that gets invoked by SNS, and it receives an event with a number of SNS records. It comes in as an array of records, but I've only ever seen it come in one at a time, so I don't know why they did it that way. They might change the way it works in the future. And so all I do is get the message out of that, the sort of message to send to the user out of that SNS message, and then I use a Slack webhook to send that message to the user. So let's have a look at how that works. I kind of hoped that we might have actually had a notification pop up while I'm talking. As you can see, I've been publishing levels this whole time. Oh, we got pretty close, but nothing was below 2.5. So let's send a single message at 1.5 and see what happens. So that's just published up, and then it's come through to my Slack channel here. It's not a very exciting bot. All it does is tell me this, but it's pretty amazing, I think, with such a minimal amount of code that I can publish a message and have it go through all these different systems and get to me in the end. So now that my garden's telling me when I need to water it, I also need to be able to see the history and understand how bad I am at watering my garden. And as I said before, there's two parts to this. There's the web client and the web backend. So on the backend, we've got a GraphQL API endpoint, which I'll talk about in a bit more depth later. And on the front end, it's just a React single page application. So I always forget this. They both use Auth0 for authentication. So Auth0 is this authentication as a service provider. Has anyone heard of it or used it before? Yeah, it's really good. You shouldn't be writing your own authentication stuff. If you can, you should just be using something like them, because they allow you to integrate with things like social providers as well as SAML. I've written a SAML library in .NET, and it's not something you want to do. If you have to work with SAML, then see if you can make it someone else's problem. And that's kind of the point of this serverless stuff, outsourcing these things to other people. But I'm going to talk about Authorizer in a second, but first, just in case anyone's unfamiliar with it, what is API Gateway? API Gateway is a HTTP endpoint as a service. So Lambda itself doesn't really know anything about requests or responses. It's just events, and these events are just JSON objects. So API Gateway integrates with Lambda and converts your HTTP requests into an event that is then invoked on Lambda, and then maps the response that you return from Lambda to a web response. It's got a lot of cool features built into it. Like, it kind of acts like CloudFront, so you have your requests come into like an edge location really close to your user, but your Lambda function might be sitting somewhere in the US. The other really cool thing, which I'll show you in a second, is that you can delegate authorization. So your Lambda functions that handle APIs or your backend code doesn't actually most of the time have to know about how you protect this endpoint. So I use Auth0, as I mentioned. It's just like a JavaScript library that you can drop into your front end. There's, this is a React front end, and there was some nice libraries to help do that with React, but there's lots of other libraries. Auth0's developer relations team is really good. They support lots of different stuff. And it just renders a login form. It uses OpenID to interact with Auth0, and then returns you a JSON web token. So in my front end, I then just grab that JSON web token, which I've stored in local storage, and I append that to the authorization header of all my requests. So on the back end, what I have to do is I have to create this custom authorizer. And the custom authorizer is invoked by API Gateway when it needs to authorize a request. You can cache it, so it's not invoked necessarily for every request, but it could be if you wanted it to. So what you get out of it is you get this authorization token from the event, which is effectively a header. I'm not going to go too into depth about the custom authorizer, but basically I get some details out of the method ARN, which is Amazon's resource name. I just have to parse it, and then I send that token back to Auth0 and say, is this a valid token? And from that, I build a policy saying that the user is allowed to access this GraphQL endpoint. So let's have a look a bit about how that works and how the what the dashboard looks like. So right now I'm logged out, and it's kind of cool, it remembers who the last person was. I just have to click login with Google, choose one of my many accounts. I then get logged in. It's stored the ID token, and then I'm sending that token along with my GraphQL query to my backend and getting data to render my chart of my moisture. So the data that you're seeing here is the data that's been chugging along during this presentation. So it was nice and smooth until I sent that one demo one for the notification. All right, so what is GraphQL? I really wanted to talk about GraphQL because being a JavaScript course, JavaScript meetup, and it's a kind of a new sort of, I don't know what to call it, framework, I guess, out there. It's really interesting. I got to play with it because I was building a system that doesn't matter, so you can do whatever you want, but I found it really, really good. So GraphQL is an application query language. You define a schema, and this is an example from GitHub's new GraphQL API. You then define a query, and you send that query to the endpoint, and you get results. So why would you use it? You can develop these systems where you have one endpoint to access all your data. All you have to do to get your data is send a query to this one endpoint, and then it understands that query and returns the data back to you. It means that the client chooses what data it's going to get rather than the server. So with a REST API, it's got a defined contract that can't be changed unless you want to do something complicated to do that. With this, I say, I want moisture data, and I want the date and the level that that event occurred, but I could just get the level if I didn't care about the date. And people tout it as having like no versioning, and to some degree that's correct, but the way it works is you'd still have to resolve your queries. You could deprecate a supported query and take it away eventually, but you couldn't just pull it from someone and break their system. But you don't have, say, versions in the header or versions in the URL, that kind of thing. So I'm not so sure about that one, basically. So what does a GraphQL query look like? This is what I use for that chart. Are many people here familiar with React, or a little bit? So I'm using this really good client called the Apollo client for GraphQL, and they've got many plugins for React and other systems, but I'm using their React one. Basically, to get the data, I just say, I want moisture data over the last X amount of hours from this particular client, and give me this field back. These fields back. Another really good part of it is that I can then specify it to poll that endpoint every 30 seconds. And it's just super easy. Drop that in and you're suddenly getting data, and you can change it, and the data is just different. The part that you have to really then work out and consider is how you define your schema. So the GraphQL is based on this schema that you create on the back end. So a schema is a hierarchy of types. You've got Scala types, object types, and list types. And the hierarchy always has this root query type, and you can have a mutation type as well, though I haven't explored that yet. I plan to. And on that type, you can define the different fields. So here we've got the moisture field, which I kind of map mentally to the query that we just saw before. And for that moisture field, I'm saying I want a list of this moisture type. And the moisture type just has a couple of fields, a date, string, and that moisture level before. Beyond defining the types, you get a few options to specify your arguments. So I've got my client ID here and my hours here as well. And the magic and the logic really happens in this resolve function. So the resolve is where you turn that query that someone sent you into data. You get a few good things there. You get the arguments that they sent, but you also get an abstract syntax tree. So if you're doing something like building an SQL statement, or for me, querying DynamoDB, you can use in DynamoDB projection expressions or modify your select statement so that you're only actually pulling data from your data source that you want as well. So you can, that full pipeline, you can minimize the amount of data that you're sending at once. And then what does this look like in Lambda? So all Lambda needs to know about is pulls in the GraphQL library, pulls in your schema, it gets the body from the event, and then it returns your data. And this one function here is the entirety of my Lambda for the web backend. So I wanted to show a bit of a demo in Postman because I think that's a really good way to see like the actual requests and response that you get coming through. So I've got my URL for my endpoint, and I've got my GraphQL path, and then I'm going to send this query, and I'm not sure if my ID token will have expired. It hasn't. So I've sent that ID token as part of the request, and here I've only specified the moisture field. So in the data, I'm just getting that field back. I'm not getting anything else. If I just want to add the date field in there as well, and maybe specify the last 10 hours instead of the last 1 hour, that field is now there, and all of a sudden I've got a lot more data coming back. So it's a really powerful way to get access to your data. It's flexible, and I think it solves some of the issues with REST. It might not be for everyone. There's still going to be REST APIs for a long time, but if you're building something new, I would seriously have a good look at this and whether it might be useful for problems you're trying to solve. So in terms of architecting it on Lambda, you've got a couple of options. You can go with a single Lambda design where your schema and your data access is all in that one Lambda function. And so you have those resolve functions accessing different DynamoDB tables or data sources directly. The advantages of this is that it's potentially easier to manage because you've just got one Lambda function, and you have theoretically less issues with cold starts. So with Lambda, I mean, the secret sauce behind Lambda, it's not so secret, is containers. And when your container hasn't been run for a while, it actually takes a little bit of extra time to build that container up and start running it again. So if you've got this one endpoint, it's going to be hit all the time, and so it wouldn't have that cold starts issue. The drawbacks of it though is there's a file size limit on how much code you can send to Lambda, and if your GraphQL endpoint gets large, you might actually start hitting that. It also kind of breaks the principle of least access. So this one endpoint then needs to access all of my backend data, and that might not be a good way to do it. I don't think so, at least. So an alternative design is kind of like drawing from SoundCloud's backends for front ends architecture, where you have a backend service that is purely interacting with other services. So in this case, my GraphQL Lambda, all it knows is about the schema, and then to resolve the data, it invokes another Lambda function, potentially in another service, to then go and get that data and have that returned to the GraphQL and then ultimately to the client. The advantages of that is that you avoid one large Lambda function. You can apply that principles of least access. So your GraphQL handler only has to invoke other Lambdas, and then each other service only has access to the data that it should have access to. I think it's a lot higher cohesion and there's a lot less coupling there. But the disadvantages of this is that you add in some extra points of failure between your like network failures and invoking those other functions, and there's probably a bit of extra latency. But that it would depend on how big your API is and what you're actually trying to do, but I would say that this second design is probably a better option. So, to summarize, serverless is really definitely a bit of a buzzword at the moment. I got into it only in February this year. It hasn't been around very long. We joke around saying there's no 10-year experts in serverless, but it does allow you to build these really cool event-driven systems. Not just cool, I shouldn't say it like that. I think it's cool because of this project I made, but it's actually like something, if you could take it and apply it in a business, that could be a source of competitive advantage. That's one of our sources, I believe, of competitive advantage at Cloud Guru. You can build these powerful systems with just very little code. So the advantages, based on my experiences, were that I didn't manage a single server during this project, which was fantastic. I might not have done it otherwise. It cost me nothing to do this entire project. If I was doing this with a project that was running servers and I just wanted to leave it running, eventually it's probably going to cost me something, but this was completely free. Using these best-in-class star AS, because there's so many like BAS or whatever, different AS services, was really good. Like, I come from a world where we used to build everything. We were just not allowed to use these services, but to be able to use them was really, really a good experience. It meant I could focus on creating functionality rather than developing authentication frameworks and getting into the weeds of that. And I could iterate over this quickly and potentially scale it. There's some alternative options. I could have used in the IoT service things called device shadows, which would have allowed me to store and then get the current state of my devices. It's something I want to play with going in the future. I could have used a monolithic Lambda for the notification service, but I sort of explained why I don't want to do that. I think I like the design that I chose better. I could have used other chat services like Messenger, SMS, and I could have used those alongside Slack as well. With the web services, take your pick of front-end frameworks. That's really not, it doesn't matter with serverless, use whatever. I could have used Elasticsearch instead of DynamoDB, which if I was building this for real, I probably would have looked at doing that because of the better querying ability. It probably suits a dashboard better, but I would have had to be running an Elasticsearch cluster. Even though Amazon can manage that for you, I'm still dealing with servers and I didn't want to do that for this project. And I also should have had the web service own the data store. So I'll talk about that in a second. So what did I learn out of this? To build serverless systems, you need to know code, but you also need to know a bit of architecture stuff. So you really need to know services, you know your services well. So the main mistake I made, and I haven't resolved it yet, is that AWS IoT service requires TLS 1.2 for authentication. And the device I bought supports TLS 1.1 because it was about $9 from China, which is much cheaper than the $50, $100 devices that you can buy. So I could have gone into C and custom firmwares and maybe got it to work, but I just didn't. And I bought myself a more expensive device, and so I plan to use that going forward. You also need to know what services exist. It's really worth researching what's out there because it allows you to use the best-in-class services rather than just using what you already know about. So when I went into this, I was thinking front-end web app hosting, S3 CloudFront, because that's what I kind of knew about. But that combo always pissed me off. It doesn't work for single-page applications very well at all. So, but I found out about Firebase hosting, and I've since found out about a service called Netlify, and they're really good, and they work for single-page applications like perfectly. So knowing what services exist can save you a lot of time when you get to use the best one. selecting boundaries in microservices is really hard. It's probably the hardest problem. I started this as a monolithic project. There's some good reasons to do that. I think Marvin Fowler did a really good series of articles about why that's the case. But a good rule of microservices is that each service should own its own data. If you start breaking that, you have problems with deployments and how the services get coupled together. And so at the moment, my IoT service owns the DynamoDB table that is used by my web backend. And it really shouldn't be like that. I did it that way because it was easier with CloudFormation to put it all there. But what I should have is the rules engine, the action for my rules engine, and the DynamoDB table in my web backend service, so I could change that as I need to. Automation is 100% always worth it. I set up Travis CI really early on in this project, and I've deployed this project so many times since setting that up, and it's just saved me so much time. Testing, unit testing, also really worth it. It seems like it's going to take more time, but when it catches bugs that you then don't have to debug, you've saved time. GraphQL is awesome. I'm still learning about it. I'm not an expert by any means, but I think I would recommend going and checking it out. It's really cool. There's a few resources here. So the project's up on GitHub at github.com/gardenaid. I also blogged about this project in detail at a blog called Serverless Zone. That's got a whole bunch of different people in the serverless community writing about what they're doing. It's really quite good. And then the tools I used were the serverless framework at serverless.com, AWS, Firebase, and Auth0. Thanks for listening. If this topic was interesting to you and you want to know more about serverless, we're actually starting a serverless meetup in November, and thanks Kevin for letting us do a shout out to that. We're going to go through introducing serverless again, and then get people to talk about AWS and Azure, and really try to talk about all the different services that are there. And if you want to learn more about AWS Lambda, don't forget we've got that free course at brisbanejs.acloud.guru. That's made by a guy called Ryan Scott Brown, who runs a blog called serverlesscode.com. He's really knowledgeable, and yeah, he's done a good job. So, any questions?
Stunned.
Stunned, yeah.
Surely you've all got questions. There's got to be something.
If you have, sorry.
That GraphQL stuff you're doing.
Yeah.
The GraphQL stuff, that was client and server, you had that?
Yeah, so the client just has to mainly know about the query. You can drop in all the libraries for like parsing it and that kind of thing. The most of that goes into the server in terms of defining your schema and then resolving it. It's definitely on both sides.
And then the main difficulty is taking that graph query and then turning that into, say, SQL or something else.
Yeah, I mean, it depends how far you want to go. I didn't go to the point where I'm getting deep into the abstract syntax tree to really optimize those queries. For this project, I've started looking at that for another project. But in terms of just resolving the functions, it's mainly those arguments. So you can get a few arguments in and say, I want this data, and then return that. If you would like over return, so my project always from DynamoDB returns those data moisture fields, GraphQL won't send that back then across the network to the client. It'll know to pick out which fields to send. Yeah. Yeah?
For the latency, when you start, or when Amazon starts up a container, what kind of time do you look at there? If you leave that service alone? For the latency, what are you looking at? If you use it overnight, what are you looking at?
I don't know like a particular number off the top of my head. I don't think there is an answer for like the number that it should be. But my understanding would be like a few seconds, probably no more than like, I don't know, just maybe like 2 to 3 seconds, I think. It's usually entirely acceptable. Some people, what they do is they use CloudWatch and CloudWatch events to just hit their Lambda on a schedule to just keep it warm, and that's like a reasonably good practice. Yeah. Yeah.
I tried Lambda and Anger at my work.
Yeah. Okay.
And I have two comments on which I didn't notice you made. First one was if you've written something in Node and it depends on the library in the operating system, deploying said library into Lambda is an absolute nightmare.
Yeah.
There are no good tools for it. The second observation we made was you can get very throttled very easily on Lambda.
So
You can get
throttled.
throttled very
Yeah.
easily on Lambda. So
Did you raise your service limits?
Yeah, we did.
Okay.
We did. The long and the short of it is we ended up pulling the services out of Lambda and
Yeah.
putting them back into Docker
Yeah.
in order to get the throughput we needed.
Yeah.
So it's just the other two gotchas you've got to watch out on.
Yeah.
The SQS one is an interesting one. We really wanted to have SQS, so particularly when you get large numbers of messages through and Lambda starts dropping messages,
Yeah.
you want to have a way to be able to bring that in. So we raised the feature request with Amazon,
Yeah.
and apparently it's coming.
Yeah, I spoke to someone who said, oh, I imagine they'll do that. So, you know, I imagine it's coming, but I don't know anything. And I think it all depends on your workload. For our workload at A Cloud Guru, as far as I'm aware, don't have any kind of service limit issues. Yeah, it really does depend on your workload. Lambda's ideally set up for these like short, quick events. You don't really want to be running anything that's long processing tasks on there. Otherwise, you might start getting throttled and hitting timeout issues. But that is a really good system for a lot of workloads. Web requests should just be short events. And if you do need to do longer processing, you can always potentially design systems where part of it is perhaps in Lambda and then part of it's, you know, in, say, a more traditional Docker cluster or something else. Yeah. Yeah.
Where does the work get done when you tailor your GraphQL queries for different databases? Like if you like Elasticsearch, you'd go into one of your lambdas
Yeah.
and rejig it so it returns a
Yeah.
GraphQL result.
So that's in that resolve function that I mentioned. Oh, whoops, wrong project. Anyway. Yeah, it's in the resolve function. I'll see if I can bring it up for you.
Are the different database vendors sort of working to meet that, like with a generic sort of query?
There's nothing special, I don't think, that you have to do. I mean, for this project, I used a library called Vogels, which is just like a DynamoDB ORM. Sorry, I'll go to the slides. But it's that resolve function. So you can use any of your existing Node libraries to access that data. There's nothing special there. You don't need vendors to do anything in particular to allow you to access that.
Just as long as it returns a promise, right?
Just
the result is
a promise, yeah, promises is how it works, but you can do it with callbacks as well, I guess. Yeah. Oh, what's happened to my
Some people have
slides?
written some libraries that will actually respect that law.
Yeah.
Reduce the graph to law like you go forward.
Yeah, I'm writing one for DynamoDB at the moment as for fun to learn about the abstract syntax trees, and I'm sure if you go research them, you'll find stuff like that. I don't know anything in particular at the moment, but it's really, really new. I think GitHub's the only one that's really doing something big in production with it, and they've done quite a few talks about their new API. But yeah, maybe you could go make something yourself if you just wanted to add to the ecosystem of JavaScript.
Doesn't need more ad.
All right, well, can everyone give him a round of applause?